Alright, so straight up using the calculator here, but I'm going to be very careful. So I'm going to do numerator and then denominator and then fix that up. So let's try the top first. So 8.9 plus 31.6. Straight up on the calculator gives us 40.5. And then denominator 0.75 multiplied by 5.4. And straight up on the calculator we get 4.05. Very interesting. And so 40.5 divided by 4.05 gives us 10. Well, we didn't need the calculator for that one, but just to make sure, right? The value of 3.9 tan to the 18 degrees correct to 1 decimal place. Okay, so 3.9, and let me just find the tan of 18. So I'll just punch in on the calculator tan 18, and we get, and they want it to 1 decimal place, but in doing the working I'll take a few decimal places. So just to be safe, let me just take about 4 decimal places. 3249, right? The next number is 1. So now we can multiply the 3.9 to that. So multiply, and I'm just gonna press multiply on the calculator. So the calculator is actually multiplying the full answer, not just the 4 decimal places that we have, but the full answer multiplied by 3.9 equals, and I get 1.2672. Right, that's the 4 decimal places, and then to 1 decimal place about 1.3 to 1 dp. So Ria is paid at a rate of $13.50 per hour. During a certain week, she worked for 40 hours. How much did she earn that week? So that's just a straight up $13.50 multiplied by 40. To give us about $540 on the calculator. Okay, so part 2, Ria worked 4 weeks in the month of August. And remember how I tell you to read a question. I'm not even gonna bother read the rest of the question. I'm just gonna say, well, alright. If she worked 4 weeks, she working for $540 per week, right? So $13.50 per hour, $540 per week. So for 4 weeks implies $540 times 4, which gives us 540 times 4 is 2160, and this will be per month, right? Or per every 4 weeks, yeah? Alright, so Ria worked 4 weeks in the month of August. You see, I even read the rest of the question yet, and I already got all of that information. This is how you had to read a question, right? You don't read it like a paragraph. And, there's a big word, her gross earnings was this. Alright, so we could see that the gross earnings is more than, what it's supposed to be, right? So that means that probably she would have worked overtime, right? Her regular week comprised of 40 hours. So this is the normal 40-hour work week, yeah? And overtime was paid at 1.5 times the hourly rate. Literally 1.5 times the hourly rate. Alright. So show that Ria worked 15 hours overtime. Okay, so it's an overtime question, right? So we see in here, alright, how much overtime? Well, this is how much she worked for. So we will have the 2463.75, and we'll minus the 2160. And what do we get for that? 2463.75 minus 2160 is 303.75. So okay, this is how much she made with overtime. And So she was paid 1.5 times the hourly rate. So the hourly rate is the normal hourly rate is this, but for overtime she was paid 1.5 times the hourly rate. Right? So this is how much she would get for each hour of overtime, 1.5 times the normal rate, right? And how much hours did she work? So how much hours did she work, right? That's what we want to show. We want to show that the hours is 15, so hopefully we get 15. And that should equal to the amount of money that she got from overtime, 7.5, yeah? And so H would be the 303.75 divided, because you could think of multiplication as one number. Throw this across. It'll be divided by 1.5. Let's call it 1.5 times 13.50. 1.5 is 1.5. Yeah? And so H now works out to be 15. So in August, 20% of Ria's gross earnings was deducted as tax. So gross and net, just as a reminder, how much money you make total, that is the gross. And then we minus tax or expenses or whatever, and how much money you actually take home, that is the net. Yeah. So how much money does she have left after the deduction? Well, I guess, because how much money did she earn? 2463.575. So 2463.75. And I guess we just have to find 20% of that. And so it'll just be 1/5, which works out to be about $492.75. And so how much money does she have left after the deduction? So it'll be 2463.75 minus 492.75, and we will end up with about $1,971. So Ria invested $219 of her earnings for 3 years. Ooh, I smell simple interest coming on, at a rate of 4.5% per annum, simple interest. How much interest does she receive after 3 years? Well, I only know one thing about simple interest, really, and that is principal by rate by time over 100, and therefore the simple interest would be the principal. This is principal. This is the rate. We leave the rate in years. This is the time. No, sorry. This is the time. We leave the time in years. This is the rate, 4.5%. So principal 219 times rate 4.5 times 3 all over 100. And she will actually get an interest of $29.57. Okay, number 2, factorize completely. We have 3n squared plus 15np. And I could see a couple of things in common. This has 3n. They both have 3n in common. So how about if I pull 3n on the outside, and then this will just be n to give me 3n squared plus 5p. Yeah, and once these two guys make sure that inside the brackets have nothing in common, and then you know that you did it right. Because if these guys had something in common, then that means it could be factorized again, right? So yeah. The diagram below shows a quadrilateral with the length of its sides written in terms of x. So we could see that. Write an expression in terms of x for the perimeter of the quadrilateral. Express your answer in its simplest form. So the perimeter means that I have to take each side and add it to the next side. So let's take it one at a time. So let's take this 15 minus 2x, and then I have to add it to 3x minus 7, and then I have to add that to 2x plus 5, and then I have to add that to 2x minus 1. Right? And, you know, we have the associative law that could help us out. For example, this plus 2x and this minus 2x, well, that'll just give me 0. So I could cross out that. And then I'll have this 2x and this 3x, so that gives me 5x. So those we handled, and now it's just the normal numbers here. I can see that I have 15 minus 7 plus 5. Well, 15 plus 5 is 20. And then 20 minus, well, this is minus 1 and minus 7. So that's minus 8. So that'll be 20 minus 8. 20 minus 8 gives us 12, so that'll be plus 12. So 5x plus 12 is an expression for the perimeter of the entire thing. The perimeter of the quadrilateral is 32 centimeters. Find the length of the longest side of the quadrilateral. Well, interesting. We don't really know. I don't know if it's drawn to scale, so we can't really say which is the longest side for sure. We'll have to test all of them, right? So we see here that the perimeter is 5x plus 12, and it said the perimeter is 32, so P is 32. Alright, so 5x is going to give us 32 minus 12. X will be 32 minus 12 is 20 over 5, which is 4. So if x is 4, I have the 4 of them. All right, so let's see what the 4 of them are. Look, they're here, right? So I have 15 minus 2x, and then I have 3x minus 7, 2x plus 5, and 2x minus 1, right? So for all of them, I will substitute x is equal to 4 and see which is the longest one. So I have 15 minus 2 times 4. Over here, I'll have 3 times 4. You substitute in x is 4 minus 7. 2 times 4 plus 5. And then 2 times 4 minus 1. And so this one is 15, 4 2s are 8, so that'll be 15 minus 8 is 7 centimeters. They did include, once they include units, you should include units as well. That is important. Every mark is important, and you can lose marks for units. 4 3s are 12 minus 7 is 5. 4 2s are 8 plus 5 is 13, and 4 2s are 8 minus 1 is 7 centimeters. So the longest side we could see, and let's just make a final statement. Longest side is 13 centimeters. Alright, so determine all the integer values of x which satisfy the inequality. Yeah. So what do we have here? We have this thing, whatever this is, it rests between -1 and 5. So you see the less than, greater than signs here. So it means that this thing, let's call it T for thing, is less than 5, but it's greater than -1. So on the number line, -1, 5, this thing is lying between that, right? Whatever this thing. And that thing depends on what x is, right? So I'm curious to know what x is when the thing is -1, right? Because it's greater than -1. So if we know what it is, what x is at -1, then we could know what it is, anything greater, right? So let's see, 2 minus 4x over 3 equals -1. X will be, and check out how I could just do the whole algebra in one step, so I hope you could follow me. You throw across the 3, so it'll become, it'll become -1 multiplied by 3. And then you'll throw across the 2, so it'll become -2. And then you throw across the -4, so it'll become divide by -4. So I'll have -5 on -4, which is +1 1/4. All right, interesting. So when this thing is -1, x is +1 1/4. Okay, interesting. So now I wonder what this thing will be, what x will be when this thing is equal to 5, right? So this thing over 3 is equal to 5. So I'll do my one-step algebra again. 5 times 3 minus 2 divided by -4. If you're a boss, you can just do it in one step. 15 minus 2 is 13. So that is +13 on -4. So interesting. 13 on 4 is -3 1/4. So x here is -3 1/4. That is interesting. That is interesting. I would have expected this to be the negative and this to be the positive, but let's draw this on a number line and see. So the values of x on a number line. So we have 0 here, and we could see that we are between -3 1/4 and we have 1 1/4. So if this is 1, then the quarter will probably land like about here. And if this is -1, -2, -3, the -3 1/4 will probably land somewhere around there. And so we could see these integers here. And we could tell that, well, once x stays in this range, then this inequality will be true. This thing will be between -1 and 5. So therefore, the values of x and the integer value, so just the whole number with the sign, will be -3, -2, -1, 0, and 1. Now you could test this. So let's just test -2 just to see, right? So it's a test, and we will put -2 because we tested -2 in the thing. And what will we get? 4 2s are, this is 2 minus 8. No, it'll be +8 because the 4 and the 2 are negative, right? Over 3, which is 10 over 3. 10 over 3 is indeed 3 1/3. So yes, 3 1/3 does fall between -1 and 5. So yeah, this is it. So the box below contains the names of 5 quadrilaterals. So we have the trapezium, which looks like this over here. We have the rhombus, which is this one. And a rhombus is just a square that got kicked over. So it's a slanted square, you could say. We have the kite, which is over here. And we have the rectangle, which is over here. So choose the name of one quadrilateral from the box that best completes each statement. A blank has no lines of symmetry and has one rotation, a rotational symmetry of order 1. So Lines of symmetry meaning, lines that when you cut it in half, you'll have two identical sides on either side. And rotational symmetry means that if you spin it, how much, if I take the square and I spin the square, when the square rotates 90 degrees, it will look like a square. So it has a rotational symmetry of order 4 because every 90 degrees it will look like how it did at the start, right? So that is rotational symmetry. And yeah, so which one has no lines of symmetry and has rotational symmetry of just one? Well, the trapezium doesn't really have any lines of symmetry. You can't cut it in the middle or so, or even diagonally like that. And when you spin it, the only way it'll look back the same is when it comes back to the original position, right? So rotational symmetry, order 1, has no lines of symmetry. I think the trapezium will work for that. And we could use a process of elimination as well, right? Because no lines of symmetry. I think everything else here has lines of symmetry, right? The rhombus will have a slant line of symmetry like that, and another one like that. Actually, no, not that one. No, not that one, because when you fold that over, it wouldn't be exactly over one or the other. So maybe not that one, but definitely one that's vertical. All right, so number 2, a blank has exactly 2 lines of symmetry and 4 right angles. Well, we could see, this square has this line of symmetry, this line of symmetry, this line of symmetry. So more than 2 lines of symmetry, right? The kite has 1 line of symmetry, and it doesn't really have any right angles necessarily. We have 4 right angles here and 2 lines of symmetry, this and this. So it is the rectangle. Something has 1 line of symmetry but no rotational symmetry. Well, we could see that it'll have to be the kite here. It does have 1 line of symmetry, and if you spin it, it wouldn't really look like itself until it come back. So I guess there is no rotational symmetry, right? And a trapezium has rotational symmetry of order 1, depending on if it's an isosceles or whatever, or trapezoid. So yeah, kite. The diagram below shows 4 straight lines, 2 of which are parallel. Oh, we have one of these, and I'm not even going to read the question. I immediately seeing that these are alternate, so this is going to be 71. These are vertically opposite, so this is going to be 54. And then these are a co-interior, which make them supplementary. So 180 minus 54 gives us 126. So yeah, determine the values of Q and R. So they didn't ask for reasons. Give a geometrical reason why angle P is 70. They didn't ask for reasons, but I'm just gonna be really, really careful, and I'm just gonna put reasons anyway. So Q. Well, R is 54 degrees, and I'm just gonna put vertically opposite, and Q is 126 degrees, and I'm just going to put co-interior supplementary. They didn't ask me for reasons, but I just put in it anyway. I don't want to lose no marks. Now they did ask me, give a geometrical reason why the angle P is 71. And well, the angle P is simply 71 because alternate angles are equal. I hope you have better handwriting than me. The diagram below shows triangles XYZ that looks like a single prime and XYZ double prime. Right? These are usually images. Usually the object would be XYZ drawn on a square grid. The triangle XYZ, yeah, is the image of triangle XYZ. So this is the object here. After an enlargement of scale factor 2 with center 5, 1. Draw the triangle XYZ, the object for the triangle prime, XYZ prime, on the grid above. So what they say is a scale factor 2 with center 5, 1. So I'm going to find the center here being 5, 1. And of course, we're dealing with this guy here. So what I'm going to do is I'm going to draw some straight lines. So make sure in the exam you have your little geometry set and thing. And from each one of these points, I'm just going to draw a line going to the center of enlargement. And we only have to draw 2 lines, so let's just use, you don't have to draw all the lines. So let's just use this straight one here, because this straight one is quite easy to see, and it's from the center 5, 1. And so if this is 4 units, it got enlarged with a scale factor 2, so we could see here that from here to here we'll have 2 units. So 2 times the scale factor 2 will give me 4, and that means that here to here will be 1 unit for the top, and we just join this here, and this here is actually X, Y, Z. The triangle XYZ prime is mapped onto the double prime by a reflection in the line P. State the equation of the mirror line. So a reflection in the line P. We could see here 1, 2, from this point to this point. 1, 2, 3, 4, 5, 6. So 1, 2, 3. This line, and then 1, 2, 3. So yeah. So the line P, the mirror line, will be this line. And that is the line X is equal to 2. It's a vertical line. So the mirror line is the line X is equal to 2. State the functions f, g, and h. 3 functions f, g, and h are defined as, and we see f, g, and h here. What is that though? That looks like 5 to the power of x. Yeah, that is h, right? Find the value of the f of a half. So the f of x is 2x minus 1. Always write it here so that you don't mix up the f, g, and the h. Yeah, so always write the function here first, and then find the f of a half, which is 2 times a half minus 1. So 2 into 2 is 1. So the f of a half looks like it is 0, because 1 minus 1 will be 0, right? The h of 0. So first, h of x is 5 to the power of x, and so the h of 0 is 5 to the power of 0, and we all know that anything to the power of 0 is 1. The g squared of minus 3. And I actually haven't seen this one in a really long time, right? But g squared, well, first of all, g of x is 3x plus 2. 3x plus 2. And so g squared, no, you're not squaring anything. G squared is actually the g of the g of x. So you're taking the g of x and you're putting it inside itself, and that is the g squared x, right? It's not really a square. It's g2. We call it g2. So we don't really say g squared, right? But it's really the g of x inside of itself, yeah? So I will take the g of x3, and whenever I see x, I will put the g of x inside of there, 3x plus 2, and then it have this plus 2 on the outside here. So this is 3x plus 2, and then this x is the same thing, 3x plus 2. So it's like an inception kind of vibes, right? So we go in with 3 3s are 9x plus 3 2s are 6 plus 2. 6, 7, 8, so we ended up with 9x plus 8, and this is g2 of x. And now we want the g2 of minus 3. I almost missed that. So we have to take 9 minus 3 plus 8. So 8 minus 27 plus 8. 8 minus 27 is minus 19. Gf of x, giving your answer in its simplest form. So let's just write down what the f of x is. 2x minus 1. So the f of x is 2x minus 1. And let's just write down what the g of x is. 3x plus 2. Yes. 3x plus 2. Equal sign there. So therefore, the g of the f of x are taking the f of x and are putting it inside the g function. So I have the g function 3x plus 2. And I'm taking the f of x function and putting it where that x was, so that is 2x minus 1, right? So the f of x is inside of the g of x function. 3 2s are 6x. 3 times minus 1 is minus 3 plus 2, so we get 6x, 3, then minus 1. Minus 3 plus 2 is 1. It's negative 1. Alright. So that is, and of course you could just put, just to be safe, a final statement. Maybe you don't need to, but just to be safe. G inverse of x. So let's see what gx is. 3x plus 2. So gx is 3x plus 2. We will let y equals 3x plus 2. Make x the subject of the formula. So 3x plus 2 is y. X will be a throw across the 2, so it'll become y minus 2, and then a throw across the divide by 3. So therefore, now we literally just flip the x and the y. So therefore, literally just switch them, right? Y is equal to x minus 2 over 3, and therefore g inverse of x is x minus 2 over 3. Hence or otherwise, determine the value of x when g inverse x is negative, is 4. So well, g inverse of x is x minus 2 all over 3. So therefore the g inverse of, when the g inverse, they're not asking us for the g inverse of 4, you know. They're not asking us for that. No, they're not. Determine the value of x when g inverse x is 4. So they're not asking us for that. They want to know what is x when this g inverse x equals 4. Right? So this is equal to 4, this whole thing. And so we have to find what x is. So x minus 2 will be 4 times 3. and x will be 4 threes are 12 plus 2, x will be 14. So number 5, the cumulative frequency diagram below shows information about the distance, d kilometers, that each of 120 students walks to school on a particular day. So read the cumulative frequency diagram below shows the information about the distance, d kilometers. So I could see d kilometers here, and this is the amount of students, 120 students, and this is a cumulative frequency curve. So cool. How many students walked at most 1 kilometer to school on that day? 1 kilometer is this. So 1 kilometer here. Let's call it about there. And of course, you could, if you use the underneath one, that is all right. If you're off by 1 or 2, that is all right. For these graph estimations, they do give you a little bit of leeway, right? So let's see. If this is 32, 4, 6, 8. So let me call it 36, right? So 36 students. 36 students were walked for a distance of 1 kilometers, and this 36, 1 kilometers or less. They didn't walk more. They didn't walk more. So 36 students walked at most with 1 kilometer or less. So 36. And how many students? 36 students. Using the cumulative frequency diagram, determine an estimate for the median. So the median here, well, we can see that the middle of 120 is 60. And so we'll go straight across, hit that, and let me come down. So 1.1, 2, 3, 4, about 1.3. So the median distance is approximately 1.3. Determine an estimate of the median. Determine an estimate of the median distance, 1.3 kilometers. Right? The lower quartile and the interquartile range. So we know that from 0 to 3 is the range. This one in the middle here, this is Q2. If we look at Q2, these guys, this half here, this is the middle here. So that is 2.1, 2.25. So 2.25, that'll be Q3. And then if we look at this side, oops, from here, from 1.5, this side, this is the half, so that is 1.5, 0.6, 0.7, we call it 0.75, and that will be Q1. And so we can see that the lower quartile is 0.75, and the lower quartile is Q1, 0.75 kilometers. And the interquartile range will be Q3 minus Q1. So Q3, the interquartile range is Q3 minus Q1. And what you'll be getting is this distance here as your interquartile range. So the interquartile range 0.75, 2.25 minus 0.75. So 2.25 minus 0.75. 1.5 kilometers. A student is chosen at random. What is the probability that the student walked for more than 1.5 kilometers to school that day? a student is chosen at random, what is the probability that the student walked for more than 1.5 kilometers to school that day? So more than 1.5, if we look at 1.5 here, it cuts right about there. So that is 80 students. So 80 students walk a distance of 1.5, right? So that means that 120 minus 80. These are the amount of students. This here is the amount of students that walked more, right? So that when you cut them on the graph, they reach in here. They reach in more than 1.5, right? So 120 minus 80 gives us about 40 students. So 40 students out of a total of 120. So that means that what is the probability that a student chosen at random walked more than 1.5? So 40 students. So the probability of greater than 1.5 kilometers implies the amount of students that walked greater than 1.5 divided by the total number of students, which is a probability of about a third. Yep. Complete the table below. Complete the table below and use the information to calculate the estimate of the mean. You see, once you have this, f times x, that means that they'll want the mean to be the summation of f times x all over the summation of f. And in this case, the summation of f is 120. So we just have to find the summation here. So let's see. If we look at this class, they use 0.25 and they got 12 students. So let's actually see that, right? So 0.25 gave them about 12. And I'll just erase, even though you can't erase it, but I can. So 0.25, so 0.1, 0.2, this is 0.25, and that's about here. So they didn't use the midpoint because that is not 12, right? Because look, 12 is here, and you can see that they use the upper, right? So they match the 0.5 with the 12. So if we look at it here, is really the 0.5, the upper boundary that they looked at in order to get the 12. So not the midpoint, they plotted it to the upper boundary. So we will look at 2.0 and we'll find this, the number of students at 2.0. So if we look on the graph from 2.0, 2.0 is about here, and that cutting about here, and we could call that 112. So let's call that 112. So 112, remember that's cumulative frequency. So that 2.0 will be 112, and what will come over here is the 112 minus all of this that came before. So 12 plus 24, so 12 plus 24 plus 46 is 82. So all of this here is 82. So 112 minus 82, and that will give us 112 minus 82 is 30. Right? And now we come to 2.5. So 2.5 over here. Well, I mean, I guess we don't really need to, because we have You know, up to here is 112. Yeah, I know that up to here is 112. And then this is another 2, which gives you 114. So 120 is total minus 114. That means that over here is going to be about 6. Yeah, in order to give us the 120 students total. Right? So it makes sense because, you know, we have the small number rising to 24, rising to 46, then dipping back to 36 and 2, giving you that normal curve. Yeah, so it does make sense. And of course, we just have to put in this here, this midpoint between 1 and 1.5 is 1.25, 0.75. So this will be 1.75, yeah. And then 2.25, yeah. Yeah, that should be it. And over here we will have f times x, so this is what we need the midpoint for. So this will be 30 times 1.75, giving us 52.5. And then we have 6 times 2.25, giving us 13.5. And so now we have to add all of this up to get the summation of f times x. So all of this added up will be 3.0 plus 18 plus 57.5 plus 52.5, right, plus 13.5 plus 5.5, and I got about 150. And so the mean ends up being about 1.25. That is the average distance walked, so it'll be 1.25 kilometers. So at a track meet, the cylindrical container fitted with a pipe as shown in the diagram below is used to serve water to athletes. Okay. The cylindrical container of radius 12 centimeters and height 20 centimeters. So we see in here the 12 and the height 20 is completely filled with water, and the pipe fitted at the bottom dispenses water into a cone cup. The cone-shaped cups have a radius of 3 centimeters and a height of 8. So I'm seeing that here as well. Interesting. You don't normally see cones, and a lot of people definitely can't remember the volume of a cone. So I really hope that they're not gonna ask you for that. But they did ask you for it, and thankfully they gave it to you. So usually those obscure things, like the volume of a cone or the surface area of a sphere, if it's obscure like that, usually they will give you the formula. Thank God. Usually, that's not to say they can be wicked sometimes. Okay. All right, so calculate the volume of water in the cylindrical container in liters. Write your answer correct to 2 decimal places. All right, so the volume, yeah, it'll be in centimeter cubed when we find the volume. So the volume of a cylinder will be what? The area of the base, pi r squared times the height. So we have pi, r is 12 and 20, right? So we will have 12 squared times the 20. So 12 squared is 144 times 20. And then I'll multiply that by 3.14. So I'll use pi as 3.14. And I got 90.43. No. 90, oh my god, I am in a mess today. 9043.20 cm cubed. Now, If 1000 cm cubed is 1 liter, then 1 cm cubed will be 1 over 1000 liters, and 9043.20 cm cubed will be 1 over 1000 multiplied by 9043.20. 1, 2, 3. So we're talking about, because it'll be divided by 1000, 9.0432. So therefore, it's 2 decimal places. Calculate the volume of water in the cylinder in liters. It will be 9.04 liters. Water flow from a cylindrical container into the cone cups at a rate of 7.8, so 7.8 ml per second. Calculate the time taken to fill one of the empty cone-shaped cups. Alright, so first of all, we have to find the volume of a cone-shaped cup. So the volume is 1/3 pi r squared h. So the volume is going to be 1/3 times pi. R is 3 and h is 8. So R is 3 and h is 8. So V is going to be 3 squared is 9 times 8 is 72, divided by 3 is 24, multiplied by 3.14, and that is 75.36, and this will be in centimeters cubed. We should change that to liters or milliliters or whatever. So we know we could see that there are, this would be how many liters? So this would be 7. We know we had to divide by 1000. 1, 2, 3. So that'll be 0.07536 liters, and 1000 milliliters is 1 liter. So 0.07536 liters will be 1000 multiplied 1, 2, 3. So I guess a centimeter cube is pretty much a millimeter, right? 1, 2, 3. We end up with 75.36 milliliters. If 7.8 milliliters will fill in 1 second, and 1 milliliter will fill in 1 over 7.8 seconds, then 75.36 milliliters will be 1 over 7.8 multiplied by 75.36, which works out to be about 9 point, and what did they say? Calculate, give me your answer correct to the nearest second. Well, the nearest second, 9.66 seconds. The nearest second will be 10 seconds. Determine the number of empty cone cups in B that can be completely filled from the cylindrical container. So the cylindrical container is, the volume of the container is 9.04 liters. So the volume of container, or let's just say cylinder, is 9.04 liters, and the volume of the cone, as we saw, is 0.75 liters. 0. And it's not 75, now it's 0.075 liters. And so, therefore, 9.04 divided by 0.075 gives us about 120 containers. Number 7, a sequence of figures is made from lines of unit length and dots. The lines form a series of octagons and squares. The dots are placed at each vertex. The first 3 figures in the sequence are shown below. Okay. Figure 3 of the sequence is shown by itself below. Add more lines of unit length and dots to figure 3 to correctly represent figure 4. So you can see we add these and then you add another shape, and this is figure 2, so we have to add these and then another shape. So that means that we will have to add a dot here and a dot here, and then we had to add a dot here and a dot here. And then come like this, this, that. So yeah, it's not very nice, but hopefully you could draw it a little better than that. And just to make clear the amount of dots we used, we added these. These guys are the ones we added. Never use red ink on a past paper though. On your paper, please do not use red ink. Just use blue or black only. Yeah, blue or black only. So we have a sequence questions here. Number of dots and the number of unit lines that form the parameters, blah, 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 form a pattern. Values for D in the figures of a blah, blah, blah. Study the pattern of numbers in each row of the table. So yeah, definitely they just want, like all the other questions, they just want us to fill it out. So we're going to find these guys here first, the nth value. So here's how I'm going to do it. I will put the number figure 1, 2, and 3, and I'll use the numbers that I have. So this is for D, right? The number of dots. We see we have 8, we have 16, and we have 24. Well, this just looks like the 8 times table, right? 1 8 is 8. 8 2s are 16. 8 3s are 24. So this will be 8n. And now let's find for P the parameter of each figure. We have 8, we have 14, and we have 20. So this looks a little bit different. And of course we have the nth, the n, 1, 2, and 3. So we can see there that we shouldn't have 8 because 8 times 2 is 16 and we wouldn't get 14. So let's go one less. Let's go with 6. 6 ones are 6 plus 2 is 8. 6 twos are 12 plus 2 is 14. 6 threes are 18 plus 2 is 20. So yeah, I guess I was lucky. 6n plus 2. Yeah, so don't just be looking at numbers. Remember, I gave you a sequence. You want to check multiples of 2 first, or if you see it's 3, the sequences are in 3s, you could try a multiple of 3s. Always check for square numbers. Of course, you're looking for your addition and subtractions with all of those, right? And you can see here that, well, this one was 8, and this sequence looked quite similar in terms of the numbers to this sequence. So I know it wouldn't be 8 because it is 14, but I used the closest smaller thing, which is 6, in terms of a even number, right? So 6n plus 2. So that means that 4 8s are 32 is going to be here. And 6 4s are 24 25, 26 is going to be here. We have to find n here for 6n plus 2 is 86. So n will be 86 minus 2 divided by 6. So that is 84 divided by 6, which is 14. So this n is 14. So that means that 8 times 14 will give me this number here, 112. For any figure n greater than 1, the number of dots d is greater than its perimeter p. N greater than 1. So for any figure where n is greater than 1, the number of dots p is greater than its perimeter p. Determine the value of n for a figure in which the difference between d and p is 36. So the number of dots d is always greater than the perimeter. So d minus p. So that tells us it shouldn't be p minus d. It should be d minus p because the number of dots d is greater than its perimeter, right? And so what is d? D is 8n minus p is 6n plus 2. And this gives us 8 minus 6 is 2n plus 2. So d minus p is 2n plus 2, and that is 36. So determine the value of n, right, in which the difference is 36. So therefore n is going to be 36 minus 2 divided by 2, which is 34 divided by 2. So we see here we have a quadratic. F of x is 3 plus 5x minus x squared. And from the minus x squared, you know, it just in a different order, but because that a is a negative means that we could expect a maximum curve like this. These are the things that I just thinking about before, you know, before we actually get into it, right? Complete the table of values for this, right? So we have f of x is 3 plus 5x minus x squared. So the f of x when x is 0, that'll be, this will be 0, this will be 0, so we'll get 3. When x is 1, that means that we'll have 3 plus 5 times 1 minus 1 squared, which is 3 and 5 is 8 minus 1, which is 7. Then we have 9. Chances are this is going to be 7 again, and this is going to be minus 3, most likely, but let's just test it and see. The f of 4 is going to give us 3 plus 5 times 4 minus 4 squared, which is 5 4s are 20. This is 23 minus 4 4s are 16. So 23 minus 16 is indeed 7. And guessing here that the f of 6 is going to be 3 plus 5 times 6 minus 6 squared. 6 5s are 30, so that'll be 33 minus 6 6s are 36, which is indeed minus 3. So on the grid below, complete the graph of that for x's between -1 and -6. So I can see here that's what they mean, that this x value only going from -1 to 6, not -6, positive 6, right? -1 to positive 6. And so we have to complete the graph, right? So in terms of completing the graph, we have to put in those things. So 0 is 3. So when x is 0, y is 3. I'll use this blue. When x is 1, y is 7, or f of x is 7, sorry. When x is 1, f of x is 7, so we have that. And then we'll have the negative 3 on this side. When x is 6, we have the negative 3 here. And when x is 4, we had 7 again here. And so we now have to be really careful drawing our curve. So that is a good estimate for our curve there. Write down the equation of the axis of symmetry of the graph, or the axis of symmetry. And I mean, you know, with a sketch like this, it's really tough to really get where that maximum is, right? But the axis of symmetry looks like it's this guy here passing through that maximum. And that is, the axis of symmetry is the line, the vertical line x is 2.5. Yeah, so that is what it definitely looks like. So write down the equation of the axis of symmetry. X is equal to 2.5. State the maximum value of the function. Well, I mean, from the graph, you know, from the graph, it's kind of hard to tell because, you know, I don't know if the function goes like this or if it goes like this, you know. But just from our estimate from the graph, we could see, well, the x is 2.5 and the y seems to be about 9.5. Right? Because if this is 8, this is 9, and that'll be about half a 9, right? So, you know, that's what it seems to be from the graph. And obviously, we could actually check, you know, when x is 2.5, you know, so f of 2.5 will be 3 plus 5 times 2.5 is 2 2s are 4, 1 is 5 on 2, minus 5 on 2 squared. So actually, when we did the math, we actually get 9.25. So you see, you know, we were close. We were pretty close, yeah? So we could actually go and put now, you know, from the graph, we were seeing there that, you know, I mean, that quarter and that half, you know, would have been really, really easy to make a mistake. You would have gotten the 9.5 correct. You would have still get your 1 mark. But from the equation, the answer is actually 9.25, right? So that's cool that we checked. But if you did put the 9.5 from the graph, you would have still gotten the mark. Write down the coordinates of the point where the line y is equal to 3 minus a half x crosses the x-axis. Write down the coordinates of the point where the line y is equal to 3 minus a half x crosses the x-axis. So where it crosses the x-axis will be at y is 0. So 0 is equal to 3 minus a half x. Well, let me put the 0 on this side. So so this will be, you know, a half x is the same as saying x on 2, right? So 3 minus x on 2. So therefore we gonna have x to be, you throw the 3 across, it'll be negative 3, and then you throw the negative 2 across, multiply by negative 2, which is 6. So write down the coordinates of the point where the line, where that line crosses the x-axis. Well, where it crosses the x-axis, y is 6. So x is 6 because y is 0. And where crosses the y-axis, well, that is when x is 0. So when x is 0, we could see that y is easily just going to be 3. Right? And on the grid, draw the line. So 6, 0, 0, 3, we have 2 points. So we have the point 6 on the x, 0 on the y there. And then we have the point 0 on the x, 3 on the y, which is a point that we already have. And we can insert that line. And that line will look something like that. Make it a little thicker so we can see it a little better. Right? So this is the line y is equal to 3 minus a half x. Using your graph, determine the solution for the equations. Well, you can see you have the quadratic and we have the line. And normally we would solve this simultaneously. But thank God we can actually see that, it cutting at this point here. So we're using the graph, right? And that point looking like about 5.5, we could call it. Yeah, I think if I had drawn the, and you see how important it is now, how important it is to try to carefully draw that curve as carefully as possible. So if I was a little more careful with the curve, it would have been exactly 5.5, and that would have been, if this is 1, this is 2, 4, 6, 8, so 0.2. So I see in here like 0.2 on the x and 5.5 on the y. So actually we could call it, maybe we could call it like 1/4 and 5.5 estimated, right? Because if this was a little bit more, so it would have been only 5.5, and it probably would have been either here or here. So, maybe we could just call it 1/4 just because we are estimating from the graph. So we have 1/4 and 5.5 on that side, and then on this side we see it cutting here at an easy 0.3. So when x is 5.5, y is approximately 1/4, and then and if you don't have the quarter, if you put the 0.2 or you put it in decimal places, that is fine, no problem. They do have a margin of error when it comes to these things. And then when x is 0, y is 3. So those are the 2 points. And here's our friend's circle theory. The diagram below shows a circle with the points P, Q, R, and S lying on the circumference, and its center marked O, P, Q, R, S, and the center O. RP is the diameter. So RP is this. And AB is a tangent, AB, at the point P. The angle APQ, so I just see in the 3x, the 2x, and the x, they're just describing it, and they give us 54 here. Now, I'm not even going to read the rest of the question. I'm just going to try to see what I know. I could tell that this is a semicircle, so therefore this will be 90 degrees. This being the radius, OP, means that this is going to be 90 degrees with the tangent. And so I can immediately see that 2x plus 3x will be 90. So 5x is 90. So x itself, 90 divided by 5, works out to be 18. And so this here, x itself is 18 degrees, and you can see I could work out these guys here as well. So if x is 18, this is 54. I'm guessing I had to work out y and z, right? So if this is 54 and this is 18, I could work out this. That'll be 54 plus 18. 54 plus 18 is 72, so 180 minus 72. This is 108, right? So that means that this will be 108, And that means that this, remember, these two are the same, right? So it'll be 108 plus 108 is 216, and I'll take the entire 360 minus 216 to give me 144 divided by 2 is 72. So this is 72, this is 72, and if we add all of these up, we will get 360. Yeah, and so if this is 72, let's see, this is 54, and that will make this 54. 90 minus 54, which is 36. So this is 36, this is 72. So 36 plus 72 is 108. 180 minus 108 is 72. So this is 72 as well. And that means that this will be 72. So that, and if these two are 72, that means that this is an isosceles triangle. It doesn't really look isosceles-ish though, so I'm wondering if I'm correct, right? So maybe I made a mistake somewhere. Maybe the mistake is here with this piece of madness I do here, right? But let's see. Let's see exactly what the question asked for, because I just work in there and I even answered the question yet. So determine the value of the following and show detailed working where possible and give reason for your answer x, right? So for x, we could see that and let's just put the reason, right? That 2x plus 3x is 90, and the reason being that the angle P, right? The angle between the angle at P, angle of the tangent with the diameter equals 90 degrees, right? And that's a good enough reason there. And so we could put the 2x, well, plus 3x equals 90, 5x equals 90. They did say show detailed working, and therefore x equals 90 over 5, which is 18. And so we have x is 18. And of course, we have to find y and z. So let's go back and let's check out this y and z thing. So if this is 18 and this is 54, then this here, 54 plus 18 is 72, and 180 minus 72, this here is 108. All right, let's work out this over here, because that is 90. So for 54 minus 90 is just a 90 minus 54 is 36. So this is 36. So this here, you know, we have a straight line here, angles on a straight line. So this here will be 180 minus 108 is 72. All right, so this here is 72. And then 72 plus 36 is 108. So that means that this will be 72 as well, right? So y is 72, but we have to figure out how to write it, right? Let's see how is the best way we can write this. Oh, this is an interesting way. You know, and have another way that we could have worked it out that's actually a lot easier, and it'll be better for us to write as well. We could actually look at this entire triangle here. This is a triangle here. This is 18. This is 90 degrees, right? Because angles in a semicircle this form 90. So that means that this angle here will actually have to be 90 plus 18 is 108, and 180 minus 108, right? So the 90 plus the 18 is 108. and the 180 minus 108 does give us 72. So yes, we get 72 here, and this is a little bit easier to write down as well. So in terms of the reasoning, we could actually write how angle S equals 90 degrees because angles in a semicircle. That's all we need to really put, right? And therefore y is equal to 72 degrees because the angles in triangle PRS equals 180 degrees, where the angle S is 90 and the angle P, the angle at P for triangle PRS, the angle at P is 18 degrees. That is the angle at the point P for the triangle PRS. Yeah. So this is a good way to write it down, and therefore we have y is equal to 72. We have the answer there. Therefore, angle y is 72 degrees. So that's a good reasoning for y, nice and easy. So you see we found two ways, and of course angle z, right? And I will just write it here even though we know, all right, so the reasoning y and the reasoning z, well, the reasoning z is easy. So z, angle z is equal to 72 degrees because angles subtended by the same chord, and the chord is the chord PS, are equal. Right? So we have the reasoning and an easier reasoning. So you see that we worked out this 72 using all kind of magic inside here and all kind of thing. But look, we found an easier way. So definitely when you want to think about writing down reasonings, you don't want to write down a whole big long paragraph. Remember, there's only 2 marks for each one of these things. So you want to think about the easiest way to reason things out. And that is one thing I love about circle theory, is that it have more than one way to work things out, right? Ooh, bearings. The diagram below shows straight roads connecting the towns L, M, N, and R. L, M, N, and R. I could see that. LR is 18. I could see that here. LN is 12. MN is 10. And angle RLN is 25 degrees here. And LMN is 88 degrees here. And I can see we have the north line from L, and we have a bearing here of 50 degrees. Calculate the angle MLN. I've seen that at the bottom here. MLN. So we want this angle here. And we could see that, let's call this the angle L. And this will be the side L, small l. Right? So we have the side L, and we have the angle L. We have this angle M, and we have the side small m. So we could use our sine rule, right? So the sine rule being L all over the sine of L will be equal to m small m all over the sine of m, right? So L being 10 all over the sine of L is what we want to find, is equal to m being 12 all over the sine of 88. In this case, we could actually flip it, right? So we could say that the sine of L over 10 is equal to the sine of 88 over 12, and then throw the 10 across. So the sine of L will be sine of 88 all over 12 times 10. So let's find that sine of L is the sine of 88. Sine of 88 is 0.999 divided by 12 is 0.08 multiplied by 10 is 0.8, 0.833, right? And therefore L will be the sine inverse of 0.833. And yes, if you got slightly different decimal places like 832 or 834, it will not make much of a difference. So the sine inverse of that is L is approximately 56.4 degrees. Did they have calculate the angle? They didn't say to any decimal places. So I'll just use 1. So we have this angle here being 56.4 degrees. Calculate the distance NR. So NR is here. This is the length that I want. I do have the opposite angle here. However, to use the cosine rule, actually, yeah, I can use the cosine rule, because the cosine rule is if you have an angle and the two sides on either side, right? So if we call this 25, let's call this the angle L now, because it's at the point L, right? So the 25 will be the angle L now. And that means that for this shape here, this will be the side L now. So we have L and L, right? And we will actually have this, we'll use this 12 as opposite the side R. So this 12 will be the side R, and this 18 is opposite the side, the angle N. So this 18 will be the side N, small n. Right? So you see how naming these things are really important, because before we were talking about this triangle, but now we're talking about this triangle. So the names of these things all changed, right? So if I want the cosine rule, small l squared is equal to the sum of the other two sides, r squared plus n squared minus 2rn cos of the angle L that goes with the side you want to find, right? So L squared is r squared 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of 25. So L squared is 12 squared plus 18 squared is 468 minus the cos of 25. The cos of 25 is 0.9 multiplied by 2 times 12 times 18, and that will give us minus 391.5. And so L now is the square root of 468 minus this one, 468 minus 391.5, the square root of 76.5. So the square root, no, the square root of 76.5. L is equal to 8.7, about 8.7 kilometers. So yeah, so this will be about 8.7 kilometers. And I know that I got that correct because it is kind of in the range of, it's not no out of the way kind of number, like 25 or something like that, or 200 or something. That 8.7 seems reasonable to the rest of the distances we have there. Determine the bearing of town R from town L. So the bearing of town R from town L. So that's actually quite easy. This is town R and this is town L. So you have to drive from L, you're going to R. So this is the road you're driving, and the bearing from the north line will be all of this. So it'll be 50 plus 56.4. That's not 50 plus 56.4 plus 25 equals 131.4 degrees. That is the bearing of that. So the bearing of town R from town L is 134 degrees. Just put that there. Alright, so 3 points O, P, and R are shown on the grid below. O is the origin, P and R. Write the position vector of OR in the form AB. So a position vector comes from the origin. So from OR, right? That is OR. So you could see that this is the point 5 along the X and 1 up the Y. So that means that OR will be the position vector 5, 1 from the origin. Alright, so another point Q is located in such a way that QR is 2, -4. Use this information, plot the point Q on the graph. So QR is 2, -4. What does that mean? QR is 2, -4. That means that if this is the point Q, I would have to move 2 spaces horizontal and then 4 spaces vertical, and I will end up by the point R. So I can literally see that on my graph. 1, 2, 3, 4. 1, 2. The point Q would actually be here. And the point Q would be the point 3, 5. Another way to work it out is by saying, well, you know what? If QR is 2, -4, then RQ will be the negative of that, which is -2, +4. So that means from R, I would have to move 1, 2 spaces and then 4 spaces up, and I would end up back by the same Q. So the point Q is 3, 5. And plot Q on the graph. Well, we see in there on the graph there. Using that information. Well, we did use that information here. So that this would go in that space. Determine QR, the magnitude of QR. Yes, the modulus of QR. So first of all, QR is what? It is 2, -4. And I haven't seen them ask for this magnitude thing in a while, right? So the modulus or magnitude of QR is the Pythagoras theorem of QR. 2 squared plus -4 is -4, eh? Yes, it is -4. So it wouldn't really matter because it is squared, but plus -4 squared and the square root of that. So the modulus of QR, or the magnitude of QR, is 2 2s are 4 plus 4 fours are 16, square root of that. So that is the square root of 20. And the square root of 20 gives us about 4.47. That is the magnitude. And well, I don't know if it's centimeters or what, so I'll just put units. Show by calculation that OPQR is a parallelogram, and this is 3 marks, right? So this might be a little bit. OPQR is a parallelogram. So if we look at OPQR, we can actually see that OP is 1, -2, 1, 2, 3, 4. So -2, 4, that is OP. We could see that OR is 1, 2, 3, 4, 5, 1. We know that QR is 2, -4. Right? Or, you know what? Because we talked about look at this, and this is an important point, right? OP is this. So OP is going in this direction. Yeah. We talked about QR, which is going in this direction. So remember we said, well, no, well, that's because, we're trying to prove parallel. Let's go RQ. So if QR is 2, -4, then RQ will be negative in front of that, so we'll get -2 and 4. So -2, 4 is RQ. We see OR is 5, 1, and PQ is also 5, 1. So how do we prove that this is a parallelogram? Because PQ equals, the vector PQ equals the vector OR, which is the vector 5, 1. Therefore, PQ is parallel to OR. And also, we have OP is equal to RQ, which is equal to -2, 4. And therefore, OP is parallel to RQ. Hence, OPQR, is that what they wrote it as? OPQR is a parallelogram. Hence, OPQR is a parallelogram. Nice. Moving on. Calculate the value of x and the value of y in the matrix equation below. Well, this is interesting because you need to know how to multiply matrices. So when I multiply this row by this column, I will get this element. So how do I do that? I take the 1 times the -4, and then I add the 5 times 2, and that will give me that element x. So this is -4 plus 5 2s are 10 is equal to x, therefore x is 6. And if I take this and multiply it by the first column, I will get this, the lower number, because of the lower row. So that means that 2 times -4 plus 2 times y, so that's 2y, is equal to 6. So 4 2s are -8 plus 2y is 6. So 2y will be 6, 6 plus 8, which will be 14. Y will be 7. The transformation T represented by this matrix maps 2, 5 onto 5, 2. Now, you know, for matrix transformations, it have a whole bunch of matrices that you might find very hard to remember. Yeah, and just remember that sometimes you might not be able to remember which is which, but a sketch will always help you out. So let's just do a quick sketch, and I'll try to do this sketch as accurately as possible, because we kind of want to see the effect of the matrix here. But it is just a sketch. So 2, 5, 5, 2, right? So 1, 2, 3, 4, 5. Let's see about that. 1, 2, 3, 4, 5. 1, 2, 1, 2. All right. So the first point is 2, 5. So the first point is about there. That's the point S. And then the point S prime is 5, 2. That's about here. And I mean, now I'm just going to use reasoning because I can't remember all of these things. I can't remember. I am one of those delinquent students who just can't remember all of the matrices, right? So let me use, a reasoning. Yes, it could be a translation, because if this is 2, 5, and then this is 5, 2, it could be a translation, but that translation will not look like this. Translation matrices don't look like that. The translation matrix, in this case, 2, 3, 4, 5 would be 3, and then 5, it would be 3 minus 3 would be the translation here. So it's not that. It certainly may, I mean, I don't know if it could be a rotation, but one thing that I am seeing here is that we have the line y is equal to x. And remember the different types of transformations that we have. So we have reflection in the line y is equal to x. It's not a translation. Chances are it's not a rotation, but definitely it could be a reflection. It's not an enlargement. If it is a reflection, it would have to be a reflection in the line y is equal to x. So I'll just make a guess. And well, I do know that this is the correct answer. So I do know that this is a reflection in the line, line y is equal to x. A reflection. I do know that. However, most of the time students just can't remember all of the matrices. There are a lot of them to remember. It have a lot of them for rotations. It have a lot of them for transformations as well. So usually, what I did here was I used a sketch and I used some basic logic and trial and error. And so yeah, I believe that is it for this paper 2. January 22, I believe, and I'll see you for the next paper. Yeah.